Formula for finding functions of angles with right triangles. There are 6 basic functions or ratios for right triangles. These functions are for angle A. We have our right triangle, which is a scaling triangle, meaning every side is different in length, and of course it is a right triangle represented by r squared. We have our side A, our opposite side, which is opposite from angle A. We also have our side B, adjacent, which is adjacent to angle A. And we have of course, our longest side, our hypotenuse, which is labeled C, and that also is adjacent to angle A. Our 6 functions are basic 6 functions for trigonometry are. We have our A over B, A opposite over B adjacent. We also have B over A, B adjacent over A opposite. We have A over C, which would be represented as A opposite over C, our hypotenuse. B over C, B adjacent over C hypotenuse. And C over B, C would be our hypotenuse over B adjacent. And C over A, again C, our hypotenuse over A opposite. Let us look at the 6 basic trigonometric ratios or functions for a right triangle. And again, it's very critical that we understand and memorize these because this forms the basis for trigonometry. Again, we have our graphic or visual, our right triangle. Our hypotenuse is labeled C. Our side that is opposite angle A is our opposite side. And B, our side that is adjacent to angle A, is labeled our adjacent, or B. And of course we have our right triangle. Tangent. The tangent of angle A would be equal to A over B. A being the opposite side over B, the adjacent side. The cotangent of angle A is equal to B over A, or the adjacent side over the opposite side. The sine of angle A would be equal to A over C, or the opposite side over C, the hypotenuse. The cosine of angle A is equal to B over C, or B, the adjacent side over C, hypotenuse. The secant of angle A is equal to C over B, or our C side, our hypotenuse, over B, our adjacent. Our cosecant of angle A is equal to C over A. C, again, our hypotenuse, over A, our opposite side. Again, these 6 functions or ratios forms the basis for the trigonometric functions that we're going to study and apply later on through this book.
Many scientific calculators have just these 3 buttons. Sine, which is abbreviated as SIN, cosine, abbreviated as COS, and tangent, TAN. If you notice on this calculator, there are the 3. Sine, which is abbreviated SIN, cosine as COS, and tangent as TAN. And with these 3 buttons, you can solve all sorts of trigonometric problems. Now, to find the angle for angle A, you have these 3 main formulas. Sine of angle A equals side opposites, opposite of angle A, divided by the hypotenuse, which is the longest side. Cosine of angle A is side adjacent, is adjacent to the angle, divided by hypotenuse. And tangent of angle A is side opposite divided by side adjacent. And so these are the 3 main formulas, and these are the abbreviations for sine, cosine, and tangent. One of the common questions is, where will I ever be using this trigonometry? This is a common question, but it's used in many, many fields. When I was in high school, I had to take algebra, geometry, and trigonometry because I took an academic program. And I became a tool and die maker. And lo and behold, I needed algebra, geometry, and trig. And there's many other occupations where you're going to be needing this. And let me explain a little bit what a tool and die maker does. And they make dies or stamping dies. After I'm finished showing you some stamping products here, we're going to look at a video footage. And imagine how this was made. This is a scale. This is sheet metal. Look at the bent shapes. Look at the ridges. Here's an electrical outlet box. Bent, holes in it. And they make thousands and thousands of these parts. They're probably in the hundreds of thousands. All these clips with stamping dies. Anything you see made out of sheet metal that is bent is usually made with a stamping die. Or look at a pan or pots. Imagine how this was made. The tooling, the design, the algebra, geometry, and trig that was used. This is a hinge die. When I was working as a tool and die maker, after that I became a high school teacher, but when I worked as a tool and die maker, I was a foreman in the shop, and I did most of the design work to produce this hinge die. And this is used in conveyor belts. They put big, heavy belt in here, and they rivet it together, and then they put a pin inside, and that's how they combine the belts. And this is the blank of that hinge die. We stamp the holes first, and we stamp out the pieces, as you can see over here, and then it gets bent. Then gets within the cam, comes in here, bends it over. Then we have a micro switch, which is an electrical switch. And as the tooling comes along, it hits the micro switch. Then there's a cutter that comes over, cuts it, falls off, and just continues on without any person really having to watch the tooling. But usually you have someone there in case it breaks. Now what I'd like you to do is look at this video and think of all the elaborate work that was done. I can guarantee you that they use algebra, geometry, and trig. And you never know when you'll be using it also. Let's look at this video now. This is a stamping die that makes trailer hitches. First, the die cuts out the outside form for the trailer hitch. Now it is forming a small section of the ball for the trailer hitch. Now it is forming the sides for the hitch. Now the tooling is stamping in two holes by the ball of the hitch. Now it is stamping a large hole and smaller holes in back of the trailer hitch. Now the finished part is put on a conveyor belt. The finished trailer hitches fall automatically into a container. Before this progressive trailer hitch die was built, it had to be designed. You can just imagine all the algebra and geometry and trigonometry that was used to design this die. Then they make prints out of that. Then once the die is designed, then tool and die makers had to machine the various components to build this elaborate die. As I stated earlier, I became a tool and die maker, then tool designer, and I started to design dies, and then operations manager of a large tool and die stamping plant. This never would have happened if I hadn't taken higher mathematics in high school.